Basic formulas of limit. Let me show you some basic formulas of the limit. Formula number 1. Limit of sine x or x where x approaches 0 is equal to 1. This is my first formula, formula number 1. Limit of sine x or x. Whatever you have for the x, whatever you have in this region, you must have the same thing in the denominator. Like sine 2x, you must have 2x. Sine 3x, you must have 3x. Sine x, you must have x. So the limit of such expression where x approaches 0 is equal to 1. This whole thing will be 1. Formula number 2. Limit of cos x equals to 1. If I take the limit of cos x where x approaches 0 is equal to 1. No matter if you have cos 2x, cos 3x, cos 5x, whatever you have where x approaches 0, it equals to 1. This whole expression equals to 1. Formula number 3. Limit of tangent x or x where x approaches 0 equals to 1. Whatever value you have for the x here, you must have the same thing in the denominator. It's exactly like formula number 1, which was limit of sine x or x. So this time I have tangent x or x. Like for example, if I have tangent 2x, I must have 2x in the denominator. If I have tangent 3x, I must have 3x in the denominator. So whatever value you have for the x in the tangent expression, you must have that thing in the denominator. So limit of tangent x or x where x approaches 0, remember don't forget 0, where x approaches 0, it equals to 1. So this whole expression equals to 1. So I must put x approaches 0, not y approaches 0. Formula number 4. Limit of 1 plus x to the 1 over x where x approaches 0 equals to e. This whole thing is my f of x. If I have f of x 1 plus x to the 1 over x, which means that whatever value I have for the x here, I must have that value in the denominator for the x in power. Like if I have 1 plus 2x, I must have 1 over 2x. If I have 1 plus 10x, I must have 1 over 10x. So limit of 1 plus x to the 1 over x where x approaches 0, don't forget 0, it equals to e. This whole expression equals to e. It is the exponent. Formula number 5. Limit of x to the n minus a to the n over x minus a where x approaches a equals to n times a to the n minus 1. This whole thing is my f of x. If I have f of x in this form, x to the n minus a to the n or x minus a, whatever power I have for the n, I must have the same power for the constant a here. And don't forget x approaches a. It equals to n times a to the n minus 1. You must put the same n whatever you have. Like if I have x to the 2 minus a to the 2, you must have 2 times a to the 2 minus 1. Let's for example you have x to the 2 minus 5 to the 2. So I must have x minus 5. My constant a is 5. Suppose my constant a is 5 and my power of n is 2. So I must have this expression in the form x to the 2 minus 5 to the 2 or x minus 5. It must equals to 2 and n is my 2 here. N will be my 2 here. So 2 times 5 to the 2 minus 1. This will be my answer. This whole expression equals to n times a to the n minus 1. Formula number 6. Limit of log of 1 plus x or x where x approaches 0 equals to 1. This region is my f of x. My f of x is log of 1 plus x or x. The limit of this expression will be 1. So whatever thing I have for the x, I must have that stuff in the denominator as well. Like 1 plus 2x, I must have 2x in the denominator. 1 plus 8x, I must have 8x in the denominator. So the limit of log of 1 plus x or x where x approaches 0 equals to 1. Formula number 7. Limit of a to the x minus 1 over x where x approaches 0 equals to log a to the x minus 1 over x is my f of x. The power of a, which is x, equals to this x in the denominator. Suppose my a is 2 and my this part is 3x, like in this form 2 to the 3x minus 1. I must have 3x in the denominator as well. If I have 3x here, I must have 3x in the denominator. If I have 4x, I must have 4x in the denominator. So the limit of a to the x minus 1 over x, where x approaches 0, equals to log a. This whole stuff equals to log a. Formula number 8. Limit of 1 over x, where x approaches infinity, equals to 0. If I take the limit of 1 over x where x approaches infinity, it equals to 0. How? Because look, x approaches infinity. If I put 1 over infinity, it is positive infinity, not negative infinity. It means that I will have a big number in the denominator. So the bigger you have the number in the denominator, the smaller you're going to have the value. So 1 over positive infinity means that I have 1 over a huge number. So if you divide 1 by bigger numbers, you will approximately get equals to 0. It won't be exactly 0, but approximately it will be 0. Because look, infinity means there is a huge number in the denominator. So the bigger you have the number in the denominator, the smaller you will have the answer. So 1 over infinity is approximately equals to 0. It almost equals to 0. Therefore, the limit of 1 over x where x approaches positive infinity equals to 0. This whole thing equals to 0. Formula number 9. Limit of 1 over 1 minus x where x approaches negative infinity equals to 0. How? Because look, if I put 1 over 1 minus into minus infinity, it will become 1 plus positive infinity. So I will have 1 plus positive infinity because minus into minus will be plus. That is a minus infinity. If I put directly x equals to negative infinity here, since it will be a positive infinity here, which is a huge number, if I add 1 to the positive infinity, it doesn't affect anything. It is only 1. Even if I add 1000, it doesn't affect infinity because infinity is a huge number. So 1 over 1 plus positive infinity is still 1 over positive infinity. So 1 over 1 plus positive infinity is still equals to 0 because there is a huge number in the denominator. As I told you, the bigger you have the number in the denominator, the smaller you will have the value. So approximately it equals to 0, but it is not actually 0. So the limit of 1 over 1 minus x where x approaches negative infinity equals to 0. Formula number 10. Limit of 1 over x minus 1 where x approaches positive infinity equals to 0. This 1 over x minus 1 is my f of x. If I put the limit x equals to positive infinity, so I will have 1 over positive infinity minus 1. As I told you, it is a huge number. Infinity is a huge number. So no matter whatever value you subtract from the huge number or add it to the huge number, it doesn't affect. So if I subtract 1 from positive infinity, still it is a positive infinity. It doesn't affect. I subtract only 1. Even if I subtract 100 or 1000, it doesn't affect positive infinity. So 1 over positive infinity minus 1 means that 1 over a huge number equals to 0. Again, I have a huge number in the denominator. Subtracting 1 from the infinity doesn't affect the value of infinity. There is a minor difference. Therefore, this expression equals to 0. Formula number 11. Limit of e to the x where x approaches 0 equals to 1. My f of x is an exponential function here. E to the x is my f of x. If I have the limit of e to the x where x approaches 0, this thing will be 1. Formula number 12. Limit of e to the x where x approaches positive infinity equals to positive infinity. Again, my f of x is e to the x. If I take the limit of e to the x where x approaches positive infinity, so e to the positive infinity equals to positive infinity. This thing equals to positive infinity. Formula number 13. Limit of e to the x minus 1 over x where x approaches 0 equals to 1. My f of x equals to e to the x minus 1 over x. So whatever value I have for the x, like e to the 2x, I must have 2x in the denominator. If I have e to the 4x, I must have 4x in the denominator. So the limit of e to the x minus 1 over x, where x approaches 0, equals to 1. This whole expression equals to 1. Formula number 14. Limit of e to the negative x, where x approaches positive infinity, equals to limit of 1 over e to the x, where x approaches infinity, equals to 0. Since its power is in negative, so I brought this stuff to the denominator to have 1 over e to the positive x. In the denominator, e to the negative x will be e to the positive x. So the limit of 1 over e to the positive x, where x approaches infinity, which means that if I put x equals to positive infinity, I will have 1 over e to the positive infinity. It equals to 0. This thing will be 0. Formula number 15. Limit of 1 plus 1 over x to the whole x, where x approaches positive infinity, equals to e. If I have such expression where x approaches positive infinity, it equals to e. Whatever value you have for the x, you must have that value in the power. Like 1 over 3x, I must have 3x. 1 over 10x, I must have 10x here. So the limit of 1 plus 1 over x to the x, where x approaches positive infinity, equals to e. Even if I put 3x here and 3x there, ultimately it will be a positive infinity, because 3 times positive infinity is still positive infinity. It will be 1 over positive infinity to the power of positive infinity. This expression will equal to e. Formula number 16. Limit of 1 plus x to the n minus 1 over x, where x approaches 0, equals to n. F of x is 1 plus x to the n minus 1 over x. This is f of x, where x approaches 0. Again, whatever expression we have for the x here, we must have that stuff in the denominator. Like 1 plus 20x, you must have 20x here. So the limit of 1 plus x to the n minus 1 over x, where x approaches 0, equals to n. If I have 1 plus x to the 2, my answer will be 2. If I have 1 plus x to the 10, I must have 10 in the answer. This answer depends on this n. If I have an expression in this form, it equals to n. Simply put n.